Hello students, welcome to the new lecture. This is the fourth lecture in Jntuh B.Tech first year Basic Electrical Engineering first mid previous year questions and detailed solutions. And this is the first unit to last topic, that is time domain analysis or transient analysis. So we'll be discussing the questions of transient analysis, first order RL circuits and RC circuits. So let us start with the first question. So before starting with the first question, we will discuss about the properties of the three circuit components. They are resistor, inductor and capacitor. So if I take the resistor, so resistor opposes the flow of current, but it allows the sudden changes in current, it allows the sudden changes in voltage. But when we go with the inductor, inductor has a unique property, it does not allow sudden changes in current. So remember, inductor will not allow instantaneous changes in current. So coming to the capacitor, capacitor does not allow sudden changes in voltage. So capacitor is not going to allow instantaneous changes in voltage. So based on this property, so we'll discuss the initial conditions of resistor, inductor and capacitor. So what do you mean by initial conditions? So at t is equal to 0 plus, at t is equal to 0 plus and at t is equal to infinity. What is the meaning of this? Let us understand. Let us say this is one circuit. Power supply is V, and here we have a switch, and here we have R, and we have inductor L. So this switch is going to open at t is equal to 0. This arrow represents before t is equal to 0, the switch was in the open condition. At t is equal to 0, the switch is going to close. That means at t is equal to 0 plus, the switch is going to be closed and the circuit will be in the closed condition. Then we will get the closed loop. So this is the meaning of t is equal to 0. Let us say 9 a.m. is one reference time. So 8:59 is the before switching operation, t equal to 0 minus. 9:1 is the t equal to 0 plus after switching operation. Here switching operation means opening the switch or closing the switch or moving the switch from one position to the other position. But in this case, the switch was in the open position before t is equal to 0. That means t is before t is equal to 0 means it is t equal to 0 minus. It after t, immediately after t is equal to 0, immediately after the switching operation means t is equal to 0 plus. And after some time, after long time, at steady state means we call this as a t is equal infinite. T is equal infinite means it represents the steady state condition. So based on this switching operation, t is equal to 0 minus, t is equal to 0 plus and steady state condition, we will discuss the initial conditions of resistor, inductor and capacitor. See, resistor at t is equal to 0 plus how will behave, and at t is equal to infinite how will behave. There is no change in the behavior of the resistor at t is equal to 0 plus, it acts like resistor only. At t equal to infinite also it acts like resistor only. When comes to the inductor, so inductor means inductor with zero initial conditions. That means there is no initial charge in the inductor, there is no initial stored energy in the inductor, there is no initial current in the inductor. It is called inductor with zero initial conditions, or we call this as inductor with or we call this as uncharged inductor. So at t is equal to 0 plus how inductor will behave. So clearly we know that before switching operation, that means at t is equal to 0 minus, we told that there is no current in the inductor because it is an uncharged inductor. So before t is equal to 0 minus, before switching operation at t equal to 0 minus current is 0 means after switching operation also current in the inductor is going to be 0, because we know that inductor does not allow sudden changes in current. That means before switching operation if current is 0, after switching operation also current is going to be 0. That means current 0 means inductor is going to act like what? Inductor is going to act like open circuit. Uncharged inductor at t is equal to 0 plus, it acts like a open circuit. Now let us start let us look at steady state condition. At t is equal to infinite, so inductor is going to act like a short circuit. See, let us say what is the voltage across inductor? V is equal to L into di by dt. At steady state means in the circuit the current is going to be constant. So there is no change in the current, there is no transient in the current, there is no transient in the circuit. That means current in the circuit is going to be constant. So V is equal to L into d by dt of constant. Constant I is nothing but what? Constant. So d by dt of constant is equal to what? Differentiation of constant is equal to what? 0. So V is equal to L into 0. So voltage equal to 0. Voltage equal to 0 means what? Short circuit. At steady state, inductor acts as a short circuit. So what are the these initial and final conditions of the inductor? At t equal to 0 plus, it acts like an open circuit. At t equal to infinite, at steady state condition, inductor is going to be replaced with the short circuit. Now we'll talk about what are the conditions of the capacitor, initial and final conditions of the capacitor. So this is a capacitor. At t is equal to 0 minus, how it will behave, sorry, at t equal to 0 plus, how it will behave. At t is equal to infinite, how it is going to behave. So I have taken capacitor with 0 initial conditions. 0 initial conditions means initial capacitor voltage equal to 0. That means V of 0 minus is equal to 0. Or at t is equal to 0 minus, voltage across capacitor is 0. Now what is going to happen at t is equal to 0 plus? Before switching operation, the voltage in the capacitor is 0 means after switching operation also the voltage in the capacitor is going to be 0. So voltage 0 means capacitor acts as what? Short circuit. Remember, at t is equal to 0, uncharged capacitor, at t equal to 0 plus, it acts like a short circuit. Now what happens at t is equal to infinite? So we know one formula, I is equal to C dV by dt. Here you see I is equal to C into, at steady state voltage across capacitor becomes what? Constant. So differentiation of constant is equal to what? 0. So current is equal to 0 is nothing but what? Open circuit. At steady state condition, capacitor acts as a open circuit. So this is about uncharged capacitor. Uncharged capacitor with 0 initial conditions. So resistor, inductor, capacitor. Resistor allows sudden changes in current, but inductor does not allow sudden change in current. Capacitor does not allow sudden change in voltage. And how resistor, inductor, capacitor acts at t equal to 0 plus or at t is equal to infinite, that is at a steady state. Now let us start with our first question. So what is the first question is asked? The inductor does not allow sudden changes in what? Inductor is not going to allow sudden changes in current. Answer is A. Next, second question. Capacitor does not allow sudden changes in voltage. Answer is what? Capacitor is not going to allow sudden changes in voltage. Next, third question. The parameter that cannot change instantaneously in the capacitor. Instantaneously means sudden change. So in the capacitor, which parameter is not going to change instantaneously? So in capacitor, voltage is not going to change instantaneously. Next, fourth question. The transient response occurs in which circuit? Transient response occurs in only inductive circuit as well as capacitive circuits. So both B and C. As inductor does not allow sudden changes in current, it stores some energy because of that property. And as capacitor does not allow sudden changes in voltage, therefore we will be having the transient behavior in the circuit. Both in inductive circuit, both in capacitive circuit. That means answer is B and C. Next, fifth question. Transient behavior occurs in any circuit when there are sudden changes of applied voltage, the voltage source is shorted, the circuit connected or disconnected from the supply. So all the above. That means when the transients are going to occur. So usually transients means a change in the voltage or change in the current. So when that is going to happen in the circuit, whenever we suddenly apply the input supply to the circuit, whenever we suddenly disconnect the power supply, whenever we change the circuit configuration suddenly, so in all these scenarios the transients are going to occur. So answer is what? All of the above, D. Sixth question. For a DC voltage an inductor at steady state. So just now already we have discussed voltage across inductor is V is equal to L into di by dt. At steady state, current through the inductor is constant. So differentiation of this current value is constant. So differentiation of constant is what? Differentiation of constant is 0. So L into 0. So voltage is going to be 0. Voltage 0 means, it means inductor acts as what? Short circuit. So it acts like virtually short circuit. Answer is A. Next, seventh question. An initially rest inductor is connected to a DC source at t is equal to 0. Inductor behaves as. So we need to identify the inductor behavior at t is equal to 0. At t is equal to 0 means we have to understand that at t is equal to 0 plus. So at t is equal to 0 plus, how the inductor will behave, we have to understand means at t equal to 0 minus how it was. So at t equals 0 minus, is any current present in the inductor or there is no current in the inductor, we have to understand. Before t equals 0 minus, if any current present in the inductor, let us say 2 amps is present, and after t equal after switching operation at t equals 0 plus also, we will get the same current. Let us say if t equals at t is equal to 0 minus, there is no current in the inductor. At t equals 0 plus also, there will not be any current in the inductor, because inductor does not allow sudden changes in current. But at t is equal to 0 minus, so what about the inductor? See, in the question some information is given. An initially rest inductor. So an initially rest inductor means inductor with zero initial conditions. That means uncharged inductor. That means at t equals 0 minus, there is no current in the inductor. It means at t equals 0 plus also, there will not be any current. So because inductor does not allow sudden changes in current, before switching operation current is 0 means after switching operation also current is going to be 0. So current is going to be 0 means, current 0 means what? Open circuit. So answer is A. Next, eighth question. At steady state, inductor acts as, just now we have discussed, at steady state inductor is going to act as a short circuit. Next question, ninth question. Let us see the ninth question. When a series RL circuit is connected to a voltage V at t equal to 0, then the current passing through the inductor is at t equal to 0 plus. So this is a RL series circuit, plus minus V, and let us say it is switch, and this is R, and this is L, and it is R, and it is L. So at t equal to 0, the switch is going to be closed. Then at t is equal to 0 plus, after the switch is closed, what is the current through the inductor? So what is the current through the inductor means, we have to understand before switch is closed, what is the current through the inductor, we have to understand. So before the switch is closed, so switch was in the open condition. Switch was in the open condition like this. So this is a resistor and inductor R, and it is L. So as the circuit is open, there is no current flowing through the inductor. So current flowing through the inductor is what? I is equal to 0. It means I of 0 minus equal to 0. I of 0 minus equal to 0 means before switching operation, before this power supply is connected, current through the inductor is 0. As inductor does not allow sudden changes in current, before switching operation current is 0. Before power supply given to the inductor, current is 0 means after the power supply, after the switch closed also, current through the inductor is going to be 0. So answer is 0. I of 0 plus, current through the inductor after the switch is closed, also current through the inductor is going to be 0. So it acts like a open circuit. Next, it's about the time constant of RL series circuit. The time constant of RL series circuit is L by R. Time constant we denote with a tau. It is called tau. So for RL series circuit, it is L by R. It is very, very important bit. Next, time constant of RC series circuit. Time constant of RC series circuit is R into C. Tau is equal to R into C. Next, it's about the RC series circuit. A RC series circuit having R is equal to 2 ohms and C is equal to 4 microfarad. Then time constant is what? Time constant tau we need to calculate. So tau is equal to, what is the formula? R into C. R value is 2, C value is 4, so 8 seconds. So answer is what? D. Next, the time constant of capacitance circuit is defined as time during which the voltage. So here carefully see, it is about the voltage. In the question, whether it is we are talking about the voltage or current, we have to understand properly here. So how we define the time constant in the capacitive circuit in terms of the voltage. So when the voltage rises from 0 to 63.2% of its final steady state value, that is known as time constant. It is not raising up to 38.6%, it is not up to, it is not decreasing to 38.6%, it is not up, it is not falling to 63.2%, because we know, so capacitor voltage is equal to V into e power minus t by RC. So it is about whenever the capacitor voltage is changing from 0 to 63.2% of its final steady state value, that is known as time constant of RC series circuit. Next question, 14th question. The final value theorem is used to find the steady state value of the final system output. Steady state value of the final system output. So system output at steady state condition is going to be find out using the final value theorem. Answer is A. Next, 15th question. If a DC voltage of 10 volts is connected to a series combination of 10 ohm resistor and 1 microfarad capacitor, then value of the current at steady state. So what is connected here? 10 volts voltage source, and it is connected to series combination of 1 resistor and 1 capacitor. So this is resistor R, it is 10 ohm, and capacitor C value is 1 microfarad. So we have to find out the current at steady state condition. Steady state condition means we have to find out I at infinity. So we all know at steady state capacitor acts as an open circuit. So this capacitor is going to act like a open circuit. So in open circuit, current is equal to what? 0. So answer is 0 amps. Simple. I is equal to C dV by dt. So here steady state means you substitute dt is equal to infinite. So I is equal to C into dV by infinite. Something by infinite is equal to what? 0. Something by infinite is equal to 0 means current is equal to 0 means what? Open circuit. So at steady state, current through this capacitor is equal to what? 0. Answer is 0. So these are the multiple choice questions in the time response analysis or time domain analysis of first order RL RC circuits. First order RL RC circuits means RL, only one energy storage element present. It is a first order circuit. When we apply the KVL, we are going to get the first order differential equation. RC, so here only one energy storage element, first order circuit. But when we go for LC, it is a second order. When we go for RLC, it is a second order. But in our first year BEE, we have only first order circuits only. So these are the multiple choice questions from transient analysis. In the next lecture, we'll discuss about the fill in the blanks, some few fill in the blanks questions from this time domain analysis. Thank you. Have a nice day.